Hi guys, welcome to Learn Electronics Repair and the next instalment in the step-by-step GPU repair guide. So I hope you've been following this guide so far, because this is a sequence of tests which you should make in order, and at some point through the sequence you will find out what the fault is on your graphics card. So if you haven't done so far, you're trying to fix a graphics card, go back to part 1 and just follow the tests all the way through. And if, like me, you get to this point where you can't find anything obviously wrong so far, then we need to continue, and the next step is to measure some voltages. But before we measure the voltages on the graphics cards, I want to just explain to you how these cards actually power up, because it's not a case that you just switch the power on and instantly all the voltages just appear on the graphics card. There's something called a power on sequence, the power sequence, and this is the order in which the voltages come online, okay? And this needs to work as it should, otherwise the graphics card will never start. So basically, the graphics card, once you apply power, it turns the voltage rails on, as I say, in sequence. Now, this in part is done by some circuitry which you'll find on any graphics card, whether you're familiar with the card or not, just by looking. So let me show you on these cards where the circuitry that does this is actually located. So if you look at the graphics card, you'll see somewhere something like this. So we have groups of transistors all in a block here, yeah, and some little 6-pin chips as well. This is the circuitry that manages the power on sequence, the logic sequence of power. So on this card we can see we have it here, and this is a fairly small group of circuitry on this one. Let's look at this one. So again, we can just look around. There's a few transistors up here. Turn it over, let me look. Yeah, we also see a block with a lot of transistors here and here. So this, on this one, is almost certainly the circuitry which is involved in this sequence, this boot up sequence, okay? Yeah, on this one we see another similar chunk of circuitry up here, quite likely involved in the startup sequence. I don't see any other obvious candidates on this board. Yeah, another little block around here, so this also may be involved. So that's the sort of circuitry, what it physically looks like, that is involved in this startup. Now let me just explain how this sequence actually works. And it's a little bit different for Nvidia and for AMD graphics cards. Okay, let's look to see what happens. So when we first switch the PC on, we get 12 volts and 3.3 volts. So these are coming in on the PCIe connector and on the 6 and 8 way connectors. We looked at these on the last video. So we have these voltages coming in. Now, the first voltage that powers up is the 5 volt, and the 5 volt is derived from the 12 volt. It has to come from a higher supply than the output. This is a linear regulator, so ground, 5 volts. This is usually that little 78M05 or something similar. Once the 12 volt, the 5 volt and the 3.3 volts are present, that little bit of logic circuitry switches on the 1.8 volt rail. So the 1.8 volt, quite often there's a little 8-pin chip. We'll try and find out later. It could be one of those little buck converters with a coil. Quite often it's just a linear chip. And this will have various pins, and not in any particular order. You'll have voltage in. Now, the 1.8 volts could be powered from the 3.3 or the 5 or the 12. It could come from any of them. Quite often it comes from the 3.3, but as I say, it could come from any. So what do we have? We have the supply voltage in, V in, whatever rail it comes from. We have V out. This is your 1.8 volts. Okay. Now, To make this chip switch on, it has a signal on one of the pins called 1.8 volt enable or something similar to that. And the enable signal is generated by all those little transistors we can see on our board, rows of them, and they are going to be monitoring the 12 and the 5 and the 3.3, and when they see all these are present, it switches this on. It does it by putting a high voltage on there. Depends on the chip. It could be, if this is V and it's 3.3, it could be a 3.3 enable, it could be 1.8, but it puts an enable signal on here. Okay, that switches on the 1.8, and we'll talk a bit more about these enable signals in a little bit. There's another important thing we need to know. So once the 1.8 comes on, we'll look at the Nvidia graphics cards first. So on the Nvidia graphics cards, the next supply to come on is V-Core. Okay, this is usually controlled by a chip with many pins, because V-Core has a number of different phases. 12 on this board, there was 4 I think on this one, and 1 was something else. So the V-Core will be controlled by a chip somewhere in this region. On this board it's probably this one. I'd say probably, I mean we have to look up the data sheet to be sure, but on this one, this is probably controlling the V-Core and the voltage to memory controller. So these 5, that's the different one. So 1, 2, 3, 4, 5. One of them is memory controlled as a core. They've been driven by these drivers. You see a driver against each one, and they'll be controlled from here. And quite possibly this will give V-Core and the voltage for the memory controller. Okay, so that's the sort of chip we're looking for. This will be powered from the 12 volts. So V in will be 12 volts. Okay, and it needs to be enabled. Now the way it's enabled is this chip will have a 1.8 volt power grid, could maybe call something 1V8 P grid. So this power grid goes high to whatever logic level we're using when 1.8 volt is present and all the rest are present. This comes into this chip, and that enables this chip. Okay, so this chip now generates the V-Core, okay, and it sends out a signal, V-Core power grid. The datasheet will tell us which pins it's on, but we'll have a V-Core power grid. Okay? And you can sort of see where this is going. Once the V-Core power grid is up, this enables the next chip. This is a buck converter with a coil, and this one on Nvidia cards is PEX. Okay? PEX again will have V in of 12 volts. PEX is about 0.9 volts. So that goes to the enable pin on this chip. These are the enable pins. Okay. And that generates PEX. 0.9 volts. And again, it gives a signal out. PEX power good. And that goes to the next regulator that we want to switch on. With the Nvidia, the next one is the RAM and the memory controller both together. So this will go to the next controller. Again, this is another one of these chips with the coils by it. Let's have a look on one of our cards. So this one, this was the memory controller. We can see there are some MOSFETs here, 2 low side, 1 high side. These ones, if you look, these all have these driver chip. So inside there, effectively the 3 MOSFETs and some more circuitry. This has individual MOSFETs, so somewhere around here will be the controller. Well, there's a chip there, but I doubt that is the controller. I suspect on this graphics card it's probably built into this. Sometimes these controllers can handle 2 or 3 different voltage rails, so don't be surprised to find a chip that is both V-core, multiple phases, VRAM, maybe 2 phases, and V-memory controller. You may find that. Let's look at another one. This is the GTX 1080 Ti. On here we can see a controller here. This is probably the V-core. We see some smaller ones as well, so you may find that one of these is the VRAM. Okay, so these are sort of chips you're looking for. To know for certain, you'll have to either trace around or find a schematic or a board view, and we'll talk about those also a bit later. But these are the sort of chips we're looking for. So as I mentioned, VRAM, VM control, both on one. These are 2 different voltage rails. RAM, MEM control, which is part of the GPU. Okay, I'll move it from underneath me. Yeah, and that's actually the last voltage rail that comes up on our board. So once all of these voltages are there, we have another power good signal coming from here. Okay, now this power good will go into what's called an AND gate usually. So AND gate, that's a NAND gate. It could be a NAND gate, it could be an AND gate. Okay, this gives a high on the output if both the inputs are high. So the power good will normally come into something like this, and the other thing that's coming in is from your PCI connector, PCI reset. So basically, when the motherboard is booted up, it takes PCI reset high, and that goes to the GPU. So GPU, and this is the reset pin. Okay, that effectively takes the reset off the GPU and allows it to run. But if the power good isn't there, so something went wrong in this sequence, this signal will be low. That has to be high as well, that one and that one, to start the GPU. So that's basically the power on and the reset. Once we get to this point, what happens now is via the PCIe, the computer asks the GPU what it is, the GPU reads the ROM, okay, BIOS, and replies back to the PCIe. So these are all the things we're going to test. We're going to check if we have the input voltages, we're going to check we have each voltage on the way through, and we're going to check if we do, then does the reset come off the GPU, okay, and if it starts, does it read the BIOS? So that's what we will test. I'll just draw the startup sequence, or rather power on sequence for the AMD cards. It's slightly different. I was just drawing out the sequence for the AMD cards as well, and the recording didn't start. It sometimes does that. So this sequence is for Nvidia cards, okay? AMD works the same, so I haven't drawn this again. It's just the order is different in which the voltages come on. So the first part is the same, 12 and 3.3 from the PCIe in the 8 and 6-way connectors. 5 comes on. That enables 1.8, 1.8 comes on. That enables PEX, PEX comes on. That enables VRAM and voltage memory controller, they come on. That enables VCore, and VCore comes on. And then the same thing, we have a power good which comes down. I've actually drawn it to the wrong place. This is from VCore, not from there, okay. So the power good comes on, we have an AND gate, we have PCIe reset, that takes the reset off the GPU and the graphics card starts. Again, the next thing that should happen is the PCIe should query the graphics card and they should talk to the BIOS, get its parameters and send them back to the PC. Therefore, the PC detects the graphics card. So that's how it works. Two things I'll mention. Firstly, I pointed out in some earlier videos that on some graphics cards, it's actually Nvidia graphics cards, I thought it was AMD. On some Nvidia graphics cards, you can have a 7.5 volt supply. So sometimes this 5 volts that we see here is 7 volts to 8 volts. This tends to be on older, earlier generation Nvidia cards. So sometimes you'll find that. The second thing is about these enable and power good signals. So if we have a chip that's sending out power good, that's a signal that says I am working. So for example, 1.8 volt power good, and then this goes in to the next in the sequence, V-core we had in here, and this is enable. Now quite often these pins are active high, so you have to have a voltage present here to switch the next voltage regulator controller on. But usually the voltage doesn't come from the chip. What actually happens is you have here a resistor up to one of the voltage rails, maybe 1.8, maybe 3.3. It could go to various ones, quite often to 3.3. And what actually happens is this resistor holds this voltage rail up by default. So this chip, instead of actually sending a power good, what it actually does is, when power is not good, it holds this down. So internally, the chip holds this line down to ground. When the 1.8 volt comes on, so you got 1.8, it's on, it just lets go of this rail. It doesn't stick 3.3 volts out, it just disconnects it from ground. And now the resistor pulls it up. Okay, this is called a pull up resistor because that's what it does, it pulls the voltage rail up. So what this means is, in practical terms, if this resistor is open circuit or it's broken off the board due to bad handling, when this chip says okay, the power's good, 1.8 up, it lets go of this rail, but there's nothing to pull it up, so it just hangs around at a low voltage and this never gets the signal. Okay, so that's just something to bear in mind if you find a power good isn't working but the regulator's already giving a good voltage. So you think, well, I've got a good 1.8, so there must be something wrong with the chip, it's not sending the power good. No, it's probably the resistor that's broken. You need to find it. If you can't find it, try sticking the resistor from there up to 3.3. Be careful, it might be 1.8. Okay, so that's the second thing. Another thing well worth mentioning, and this will depend on the type of VRM controllers, the voltage regulators. Sometimes the power good and or enable is active low. So that means instead of being taken high to enable the chip, it's taken low. Normally, if that's the case on the chip, say for example the 1.8 volts, you may find that the enable pin is like this, so like an underscore but above the word EN with the line across the top of it, and same with power good or PG with a line across it. If you see this on the data sheet or on a schematic, a board view, then you'll know it's active low. So in this case the signal goes low to 0 volts to enable the chip or to send the power good out. There are other ways this is also done. Sometimes you'll see a hash PG or EN, you might see an asterisk, we'll put enable on this one, EN. So if you see any of these symbols, it means that the signal is active low. However, what I said about pull-up resistors may well still apply. So although the signal is active low, the chip that's driving the power good, for example, if this is active low, It's not the chip that drives that high. Again, it's a pull-up resistor which holds it high until this chip pulls it down. So what shall we do? Well, we'll have a quick look. I'm going to show you where this part of the circuit is, this AND gate. And then we're going to power our graphics cards up and have a look to see what voltages we have on them. But just before that, let me show you the power sequence chart I promised you. So this is a power sequence chart, and it basically shows in time what I was just describing. So this here is from like 0 seconds when you first switch on. Yeah, and this is time. So you can see instantly 3.3 and 12 volt come up. Once they're up, 5 volt also comes up automatically. It's just a dumb regulator. And at this point here, the signal, it goes to the 1.8 volt regulator, the enable to switch it on. So it switches on. Once that's on, this sends the enable signal to the next controller. NVVDD is actually VCore. That comes on. At this point, when that's on and stable, this sends a power good to the next one, which is a PEX controller, and switches that on. And once again, once that's on and stable, this controller sends a enable to this one, and this is your RAM. Your RAM and your mem control. Okay? And the same applies for this one. It's just on this one. This is your RAM. So as I said, 12, 3.3 and 5 come on. That, it even shows now, generates 1.8 volt enable. That switches a 1.8 volt regulator on. That sends 1.8 volt power good. That switches PEX on. Okay, PEX then sends this one, PEX VDD power good. That switches on MVDD. This is your RAM. And your voltage, your mem control. And then that sends a power good, and this is your VCore. Okay. There's a slightly different sequence here on the RX 5700 and 6800. You can see it yourself. I'll give you a link to this. I'll put this on my Google Drive for you, and I'll put a link in the video description. So now we know what we should expect in the way of voltages. Let's have a quick look, as I mentioned, at the gate which handles the PCI reset. Okay, so on a PCIe card, the reset signal is on this pin. This is actually pin 11 if we count. Yep, pin 11. So it's the one just before the notch. And you'll see that it has a track which goes up this way. And it goes up towards this chip here. Let's put it under the microscope. We'll see it a little bit better. Okay, so we can see this is the reset line, the one that comes around here. Okay, and if we look where it goes, it actually goes up towards our chip, this one, and you can see it's actually there. The one that comes to this little wire then goes underneath it. Okay, so that's the reset line. Now the other one going underneath, this one, comes down here through a wire to the board. So this is the power good, basically. The fact there's a wire here makes me think there's possibly some other circuitry on here which can also hold the GPU and reset for whatever reason. But basically with this thing will be an AND gate. Again, we'll have to look up the data sheet. But what you have in here is an AND gate. So you have two inputs, one output, a power and a ground. Okay, there's another track here going this way. I mean, that one could be the output, it could be another input, there's another one coming here. So really we need the data sheet. But what we should have on here is 3.3 volts, most certainly. Ground, we'll have two inputs and one out. And when both inputs are high, the output goes high. And that's what signals the GPU to start executing its code, start running, okay? So that's one example. Here's another one. Now on this one we can see that the track just goes straight to a via here. I'm just looking around. I mean, there's a transistor there. Okay, I moved away from the microscope. Yeah, on this one I can see the chip will be that one. You see it's like a little 5-pin chip again somewhere near the PCI. So on this one we have a chip here. You can be fairly confident that will be also part of the reset circuitry on this board. There, okay, so this is mounted on the other side of the board. That's why we had the via going through. So that will be the same sort of thing on this board. Bit of a mess on this board, by the way, but you can clean that off. It's just goo. Yeah. Sometimes you won't find this little circuit. In some cases, the reset just goes directly to the GPU, and there's logic circuitry in the GPU which also kind of does the power good thing as well, and itself that's where that happens. So sometimes you might not find it, but on a lot of boards you will find it, and this is a very good place to test to see if the graphics card is being told to start, okay, and if the power good is allowing it to do so. So what have we learnt in this episode? Well, we've learnt about the power on sequence. Hope you found that interesting. Maybe it's just a refresher for you. Maybe you didn't know. If you didn't know, you've certainly learnt something useful here regards graphics card repair. And we know what we need to look for now when we power the graphics cards up. So in the next episode, we're going to power up our graphics cards. Not this one, because we already know this one has a burnt out CPU from an earlier episode, but these three. And let's see if all the voltages are present. There's a little trick to doing this actually, which saves a bit of time. So let's learn what that is next time, okay? See you all soon, guys. Ciao for now.